Hello, chemistry students. Oops, sorry about that. Someone was turning in some homework. All right, so homework corrections for page 250, number 19. So, number 19 says isopropyl alcohol burns in air according to this equation. Letter A, calculate the moles of oxygen needed to react with 3.40 moles of isopropyl alcohol. So this problem is asking, and again, I like to kind of summarize it underneath. This problem is asking 3.40 moles of isopropyl alcohol. How many moles of oxygen do we need to react with it? Okay, so that's what it's asking us to do. Again, we're going to start with our given, which is 3.40 moles of our alcohol. Okay. Now, again, we're being asked to change from one substance to another, and our only way to change from one substance to another is to use a mole ratio. So, again, moles of isopropyl alcohol have to go on the bottom so that they will cross out. And I know I want moles of oxygen because I'm being asked about oxygen on the top. Now, this is my mole ratio, and the numbers for my mole ratio come from the coefficients of my balanced equation. So my coefficient in front of oxygen is 9, and in front of isopropyl alcohol it's 2. Now, mathematically, right, I am going to take 3.40, multiply it by 9, and take that answer and divide by 2. Remember, I have to multiply by numbers in the numerator and divide by numbers in the denominator. 3.40 has 3 significant figures, so I want to make sure that my answer has 3 significant figures at the end, and you should get 15.3 moles of oxygen as your answer. So what this is saying is to react with all 3.40 moles of isopropyl alcohol, I'm going to need 9 moles of oxygen. Letter B says find the moles of each product formed when 3.40 moles of isopropyl alcohol reacts with oxygen. So we're starting with the same given, right? They're giving me 3.40 moles. But this time we're asked to calculate how many moles of each product. That's going to require 2 problems, and it does not matter which one I do first. Okay, so you guys know I'm pretty much a linear thinker, so I'm going to do the carbon dioxide first because it's written first in the products. Okay, so again, I'm going to start my problem the same way. I start with my given, so my moles of my alcohol. Again, I'm asked to change from one substance to another, so I'm going to have to use a mole ratio. Moles of alcohol are going to go on the bottom because they're in the numerator to start. And in the numerator, I'm going to have moles, and because I'm doing carbon dioxide first, this is going to be moles of carbon dioxide. Moles are crossing out. Again, this conversion factor is my mole ratio. And my numbers for my mole ratio come from my coefficients. So my coefficient on carbon dioxide is 6. My coefficient on isopropyl alcohol is 2. Okay, now you can be smart when you put that in your calculator, but when you write it in your problem, you do have to write it as 6 and 2. Again, I have to take 3.4, multiply it by 6, and divide it by 2. Okay, when you do that, you should get 10.2 moles of carbon dioxide. Okay, always have to have units on our answers as well because again, a number without units doesn't make any sense. Now to do the second part of this problem, I'm still going to start with my given. And I always want to start with my given. I don't want to start with something I've calculated in case by chance I've made a calculation mistake. Okay, so again, my moles of my isopropyl alcohol are going to go in the denominator, and in the numerator this time I'm going to have moles but of water because I'm trying to get that other substance. Again, this is still my mole ratio, so my coefficients come from my balanced chemical equation. So my coefficient on water is 8, and my coefficient on isopropyl alcohol is 2. So again, I'm going to take 3.4, multiply it by 8, divide by 2. Okay? And again, I'm going to have 13.6 moles of water. So I hope that helps if you had some questions about that homework assignment. Have a good day.